Hello everyone, myself Sahana and today I'm here to explain the topic on software architecture and design patterns, that is conceptual classes and relationships. Let us know what are in the contents. Introduction, what is UML, types of UML diagrams, relationships and its types, benefits of defining the conceptual classes and relationships, and conclusion. Introduction. The conceptual classes is the domain model illustrates the conceptual classes or the vocabulary in the domain, like informally, formally, symbol, intension, and extension. In the informally, a conceptual class is an idea, thing, or any object. In the formally, a conceptual classes may be considered in terms of its symbol, intention, and extension. In the symbol, that words or the images representing a conceptual classes. In the intention, the definition of a conceptual classes. Extension, like the set of examples to which the conceptual class applies. For example, the conceptual classes for the event of a purchase transaction consists of the name, that is sale, in the intention of a sale that represents the event of a purchase transaction and as a date and time. In the extension of a sale, the set of all the sale it contains. Let us discuss what is UML. It is a standardized graphical modeling language for communicating the software design. It will allow a implementation like independent specification of user or the system, which will interactions like required behaviors for partitioning of responsibility in the integration with larger or existing systems, data flow and dependency operation orderings like algorithms, concurrent operations, and also pretty pictures. In the UML, is it not a process because that is it doesn't tell you how to do the things, only what you should do. Here are the types of UML diagrams. There are different types of UML diagram, each with slightly different syntax rules like use cases, class diagrams, sequence diagrams, package diagrams, state diagrams, activity diagrams, and deployment diagram. Let us discuss what is relationships in the software architecture. A relationship is what a class or an object that knows about another class or an object. In the generalization, class to class, in the superclass or subclass. In the inheritance, for example, it is a person like faculty person, student person, or the staff person. In the example of mode of travel, it may be a aeroplane, train, auto, cycle, or an boat. In the associations, like faculty information to the course information, from student information to the course information. In the aggregations and composition, like whole part assembly. In the paths group, like members. In the container, that is contents. Here we can see that relationships exist to show the relationships, enforce the integrity, and help produce the results. In this example, we can see that student in course, it considers the information about student and also the university course, hence it is related to each other. In the class diagram, relationships, in the class, that is generalization, while in the object, association, aggregation, and composition. Let us discuss the types of relationships. Firstly, in the associations, it is a link between two classes, for example, a customer has an order. In the generalizations, it is a inheritance relationship, for example, vehicle as a superclass for car and also a bike. In the dependencies, class A will depends on class B if it uses it temporarily, like a method parameter. In the aggregation, whole part, like relationship where parts can exist independently, for example, library contain the books. Composition that's strong, like whole part where the part cannot exist without the whole, for example, car as an engine. Here is the association relationships, and its definition tells that logical link between two or more classes. For example, the student will enroll in a many courses, and also the order includes the many products. In the multiplicity, it explains how many instances of one class will relate to one instance of another class. For example, one to one to many. In this example, we can see that a person is an employee to the company and company consists of the employer. In the generalization and specialization, the generalization is a defining commonalities in a superclass. The specialization will extending a superclass to create the specialized subclasses. For example, employee is a superclass with subclasses of manager and also engineer. In the generalization example, we can see that faculty and student and staff are the superclass for the role. It may be the college that it consists of many superclasses. Here are the other types of relationships, that is a dependency relationships. Its definition tells it is a weaker association where one class will uses the another. For example, shopping cart depends on product for adding the items. In the use case, typically seen in the method parameters or temporary object relationships. While in the aggregation defines a loose association where part can exist independently. For example, classroom where it is aggregate as the students which is a parts of the classroom. In the composition, a stronger association where parts will do not exist independently. For example, order which contains the order items which is a part of the order. Here is the benefits of defining the conceptual classes and relationships. While it will enhance the communication, like simplifies discussion among the stakeholders, in the foundation for the design, like provides structure for detailed software models, and also like problem domain clarity, where else to identify the core components of the system. At last is conclusion. We can conclude that the conceptual classes as a building blocks, because the conceptual classes will represent the core entities in the problem domain, forming the foundation of a system's architecture, while in the relationships will bring the structure. That relationships like associations, generalization, dependencies, aggregations and compositions, all its types will define the how these entities will interact, and also enabling the complex functionality. In the clarity and communications, the conceptual classes and their relationships will provide a shared understanding for stakeholders, bridging the gap between high-level requirements and detailed design. In the foundation for robust design, define these classes and relationships is a crucial for building a modular, scalable, and maintainable system. Thank you, everyone.